All right, here we go. I hope you tried this already, but I'm just going to go over it and maybe just quickly do a check, right? So condo is shown below, below, and there's a scale factor of 7 over 400. That's good. That's exactly how we want it. No units, right? And has been used to create the diagram. So this is your diagram right here. Determine the actual dimensions of the living room. So we look at the living room here, and this would be the length and the width. So those are the dimensions, the two dimensions you need to convert. So for the length, let's say, right, we're going to do the work here. So you start with your scale factor, and over here, we're going to put the length of the diagram. Remember, diagram always goes up. So we're going to go 3.5 centimeters and figure out the length. The length, therefore, is right 3.5 times 400 divided by 7, and that would be 2 meters. Oh, sorry, 200 centimeters. My bad. Right. So if you have no other units than this one here, then that's your answer. Your answer will be in centimeters also. And if we convert that, right, we know that 1 meter has 100 centimeters. That's quite easy conversion. So length isn't, it would be 2 meters of the actual living room. And we do the same thing with the width. So you can go ahead and skip ahead if you feel like you know what's happening. And there's the width of 4 centimeters. And let's figure out what that is. That'd be 4 times 400 divided by 7. And that would be 228.57 ... That keeps going. So this would be in centimeters. So we're just going to do a quick conversion here. And I use all decimals before I get to my final answer, and that would be 2.29 meters, right? So here you have the actual dimensions. Actual dimensions are 2 meters by 2.29 meters. Okay, so there you have it. Now it's saying determine the actual dimensions of bedroom 1 of this one here. Do the exact same thing, right? Exact same thing here, length and width. And I will just run through this. This will be length and width, 2.85 centimeters. Let's figure out the length there. And of course, you can skip ahead if you know what's happening here. This would be 162.857, and it keeps going, right? When you compute that, and we're with the same units that we started with, and we're supposed to do this in meters. So 1 meter has 100 centimeters. So essentially, you just divide that by 100. So the length is 1.63 meters rounded. And for the width, we're going to do the exact same. The width is 2.65. This will be the width. That would be 208.57 ... centimeters. And we have that 1 meter has 100 centimeters. So that rounded gives you 2.09 meters. So there are the actual dimensions of that bedroom. And this is perhaps a little trickier here. Determine the actual area of your condo, right? So my idea here was for you to think maybe on what is given here. Okay, so the way I'm going to proceed with this is I will figure out this whole thing based on the diagram. So if you think of the first dimension, right, this would be the length here, 2.85 and 2.74. I'm going to add these two up. So 2.85 centimeters plus 2.74 centimeters. That gives me 5.59 centimeters, right? So that would be the overall length of the condo on the diagram. And I did the same thing down on this side. I have a bit of a problem. There's the hole punch there. But here, I just added, right, because this is length and width normally. So this is 3.4, right? So 3.04 plus the width of the living, which is 4. So that'd be 7.04 centimeters. Okay, so the whole condo, right, considering all of that based on some of the information that is given there, would give you that. Now, knowing what you know about scale factor, there are two ways of doing this now. Okay, and the first method would be figuring out the length in meters, and then the width in meters of the actual condo, and then just go length times width and we get our area. Let's do it that way first. So again, scale factor is still this, okay, that never changes. The overall length across the condo here is 5.59 centimeters. And so we'll figure out the length there. And so length is 5.59 times 400 divided by 7. That gives me 319.428, and that keeps going. Centimeters, we convert that to meters, and so my length here is 3.19 meters. And the width, some of this is repeated, right? This would be 402.28, and it keeps going centimeters. 1 meter is 100 centimeters. Cancel, cancel. So that would be 4.02 meters. So the area would be 3.19 times 4.02. That'd be 12.82 square meters. Okay, so that would be one way of doing it. Let me introduce the other method that you should be able to do by now. Okay, so how will I start? Well, I will start like this. Area of the diagram would be 7.04 centimeters times 5.59 centimeters. And what do I get there? And I want you to see how everything is connected, right? So that's 39.3536 centimeters squared. Okay. Now, I want to convert this to meters squared. So I know that 1 square meter has 10,000 square centimeters. Okay, so I literally divide my answer by 10,000. And you get 0.00. Oh, this is probably going to give you an issue perhaps on your graphing calculator, so I should use the same. So clear that. 7.04 times 5.59 divided by 10,000. And that is that. Oh no, you're good. And I won't, as 39, and that keeps going, meters squared, right? For the diagram. Now, remember this? The scale factor squared relates the areas of these two items, objects, right? So we have diagram goes up here. Meter squared, I have it. It's small, right? Because it's in meter squared. and this is going to be the area of the actual. Okay, diagram over actual, remember? So you square that, you get 49 over 400 squared, right? That's 160,000. 0.0039 keeps going over x, and here it is, right? You go 0. Oh, sorry, I'm going to use all the decimals. I'm going to use that, right? This number right here times 160,000 divided by 49. Okay. And that is 12.85 squared meters, which is very close to what we got on this side. And that is to be expected because over here we're using all decimals throughout. Here we're rounding at one point, right, before we get our area. So there you go. That's page 16. Let's go to 17. The actual dimensions of the pool are 20 by 15 feet. A scale model of the pool has a length of 30 inches. Okay, what's the scale used? So in the scale, we would go a diagram. In this case, I would go diagram to actual. Okay, and so my diagram is a scale model, so that'd be 30 inches. That's the length we're comparing. So the length, and we're assuming that this is the length of the actual, right? Length of actual pool. This one right here. So we gotta compare those two. So it goes 30 inches to 20 feet. You can actually just leave it like that. Reduce, you can divide both by 10, right? 3 inches to 2 feet. That's up to you. I will not really take marks off. So different units are okay there. For B, state the scale factor in 3 formats. And in that case, you have to do some converting. You cannot have feet and inches, right? So 20 feet, I'm going to do that here. 20 feet, 1 foot has 12 inches. Cancel, cancel. That gives you 240 inches, right? You bring that back in here. So 30 inches over 240 inches. Perfect. You got that. And if you use your calculator for this, you can cancel the zeros, right? But you can just leave it like that too. But that'd be 3 over 24, comma, right? 3 divided by 24, we can get a decimal. That'd be 0.125 times 100. That'd be 12.5%. Okay. So obviously, the actual has been reduced, right? Because k is less than 1. We always ask ourselves what happened from the actual to the diagram, right? Or what happened from the original to get the new one, right? So B is that. C, how much smaller or larger is the model? So here's where I want you to understand something. If you have a scale factor of 12.5%, right? Since the diagram, I'll write this out, has been created using a scale factor of 12.5%, right? K is less than 100%, therefore reduction. Doesn't surprise you, right? It means that 12.5% of the actual remains. So it's almost like you started with 100%, that was the actual, and you shrunk it down so that only 12.5% remains. So I kind of want you to think of it this way. If this is your bar, which is 100%, right? Sorry, a bit of an interruption there. So imagine this is your actual, is the actual or original, and this is 100%. Okay? If you now come up with a scale factor of 12.5%, you're like saying like this goes down to 12.5%. 12.5%. This is what we would call the diagram that has been, in this case, reduced, or the new, right? Depending on the wording you use. That means that this is how much was lost, right? Right? Lost basically, or reduced, and that would be 85.5%, right? If you think about that. Sorry, what am I saying? 12.5, 87.5. 87.5 lost or reduced. So I basically go 100% minus 12.5%, and I'm left with 87.5% smaller, right? So to summarize, therefore, the actual pool has been reduced by not 12.5%, that's what remains, it's 87.5%. Okay, that's important to understand. At the same time, if your percentage is more than 100%, right? You start with 100 and then you go bigger than that, right? Let's say it's 120%. That means that you have enlarged something by 20%. Okay, just understand that. So your 100 is like your baseline, and you just got to go by that. I'll have to make another video for that last page 24, okay? And also, I guess, finish D and E, so classes will start